Hey guys, this is our last video for our final assignment before the end of the year. So first, I thought we could talk about a few class announcements, and then afterwards, what you're doing today, and then after that, stay tuned for a short review of waves. All right, so first off, if you've come this far, then congratulations! You have done something completely very, very difficult, which is being able to self-monitor and kind of balance out how to do all of the school stuff that you normally do, but at home and with other responsibilities. So this is a super hard thing. You guys kicked butt though. Great job. Couple other things. So there's no physical science final. Today we are taking a quiz over waves. So in just a second, I'm just going to go into a waves review of how to take it. There's no assignment for Wednesday. I will probably post like one small check-in question and also probably like a goodbye video, honestly. And then after that though, for Wednesday, I would like you to focus on just anything that you would like to redo in order to kind of bump up your grade. If you have missing work, then that is the time to try to get it turned in if you can. I'm going to be available on and off on Google Meets and Google Hangout, and also through email, obviously, all day if you need any kind of help. If you want to work on improving your grade, check the grade book for N's. That means that I need them. X's mean that you're exempt, but anything that you've done that is an X right now just means that it's not hurting your grade. Actually doing it though will help sort of bring up your grade because it's being averaged in with your past grades. So X's or N's are kind of the way to go. If you've done every assignment and you're still kind of like, hey, it's a little borderline right now, whatever you would like, then you can also check out any of our assisted grades, and I'll go through some of what those were in just a second. Go through those. I've left comments on each one. There should be like quick fixes, like just change a couple answers, resubmit it, I'll regrade it, okay? Also, communication is going to be key here. Friday is when my grades go in, which is why Thursday night is the absolute latest you can submit either missing work or else just work that you needed to redo. If there's something that you've noticed that I haven't gotten to yet and you're like, hey, this is still an N or an X, or hey, Miss Martin, I was counted absent last week for no good reason, then now is the time to email me about those things because we all make mistakes so that I can make sure that we're all good on either side, okay? So real quick, today's assignment, there is a short Google form. It's just like, hey, how was class and what can we do better next year? Okay. And then after that, parts of a wave quiz. So I'm going to go through a short review. If you would like, you can turn this video off now. Go ahead, take the quiz. It shouldn't take you very long. It's even shorter than normal. Or you can stay tuned for the full review. Okay. So let's go over just a couple things. Number one, waves are a transfer of energy, not matter. So I saw this on a couple of things. Think about it as like, if there's a wave on the ocean, then the water that washes up on like a Florida beach isn't the water that came from across the Atlantic. It's all the water in place, kind of sloshing back and forth a little bit, but it sort of oscillates between 1 to 2 points. That same water has always been there, so the thing that's being transferred isn't really the water. Instead, it's the energy, that movement of energy. In the case of the waves, right, it's the gravitational pull of the moon on one side and then the sun on the other. Both have a lot of gravity. They affect the earth, and what's most on top of the earth? It's the water. So they're kind of in this tug of war. So back and forth, and you get this rocking tide motion. So since ocean waves are kind of our most common example of waves of how we think about it, then sometimes I find that helps. So waves in general are created by vibrations. In water, then it's the vibrations of the water molecules together. If we're thinking about sound waves, then sound waves are created by the molecules bumping into each other in the air. There's all there is to it. So there's two types of different waves. And let's talk about this a little bit. So there's mechanical and electromagnetic. That tells us the difference between how they move and what they are required to have in order to move in the first place. Then we can further break them up into transverse and longitudinal. So mechanical waves are anything that need a medium so it can move through a gas, a liquid, or a solid. So the two types that we've talked the most about are mechanical waves, things like water waves, sound waves, earthquakes, things like that. Here's some stuff about speed of sound. Some of you guys asked me this, by the way. So 330 meters per second, that's how fast sound is. It is 300 million meters per second. That's how fast light is. So way faster. That's why you usually see things before you hear them. Okay, electromagnetic waves is any type of wave that's actually like a form of radiation, right? They do not need a medium. They can travel just through empty space. So the thing about empty space is that there's not really any gas, or if there is gas, then it's really, really spread out. There's certainly no like gas that we're kind of familiar with, like oxygen. There isn't a whole lot of mass. The masses in space are pretty far apart from each other. Just think about how like the sun, the earth, all the planets, they're pretty big, but they're pretty far apart too. And then finally, it's too cold for there to be any liquids. So no liquids, not really any gases. All of the solids are pretty spaced out. Electromagnetic waves don't really have anything that they can bump into in order to cause them to go forward. So electromagnetic waves are those that don't have a medium, again, empty space, and they are radio, micro, infrared, like heat, visible light, kind of not visible for us, but ultraviolet light is something that some animals can see, X-rays, and gamma rays, and these are kind of more medical applications for us. Here's it on a spectrum. Okay, so boom, that's the speed of light. By the way, we say that's the speed of light, but that's the speed of every single electromagnetic wave whenever it travels through space. It is the fastest that we think anything can go because it doesn't really have to do anything to travel, right? Like it doesn't have to warm anybody up. And yeah, it's just crazy fast. All right, part you actually came for. So transverse waves look like sine or cosine curves or snaky snakes. See, it looks like a little snake just slithering through. The medium that it travels through should move perpendicularly to the energy. So what does this mean? This means that the wave is going from left to right, but parts of the wave are also moving up and down, back and forth. This point on the wave, if I just watched this part of the wave going, then it would go up and back down, even though the energy is moving from the left to the right. So if I drew it, I would draw an up and down and also a left to right. And that kind of cross-like pattern would be perpendicular. So it's moving perpendicularly, the movement, to the direction that the energy is going. Transverse waves, there's a couple different parts. This is very, very important. And by very, very important, I mean definitely on the quiz. The crest is the highest point. The trough is the lowest point. The amplitude is the measurement from the rest position of 0, either up to the crest, the highest point, or down to the trough. It can be either. But the amplitude is the overall height of the wave. The node is whatever part of the wave crosses that 0 boundary. Finally, wavelength tells us the distance between every single wave, either from crest to crest or trough to trough. If I had to count one wave, then I would look at it going on a full hill and then a full downhill to where from this node to this spot right here, that would be one full wave. Let's see. Oh, and one last term is frequency. Frequency is the number of waves that happen per second. the overall wave speed, the velocity of a wave. Remember we talked about velocity and speed kind of mean the same thing here. So the speed, or how fast of a wave is moving, is the wavelength times the frequency. Here's those terms again. You can also use your drawing, by the way. The period is how long it takes to complete one wave cycle. Kind of the flip-flop of that's the frequency, how many waves are made per second. We usually talk about frequency the most, though. All right, longitudinal waves look like slinkies. The most common longitudinal wave that we talk about is going to be a sound wave. Now notice how the direction of travel is just going from left to right. Well, the wave itself, though, is also moving from left to right, right? Like there's no up and down motion. So we talk about longitudinal waves move parallel from their propagation in the direction that they want to travel. So they're going in the same direction. Does that make sense? Nobody is moving up and down. Everything is moving from left to right, almost like this, as opposed to. So longitudinal waves have two different parts. The parts where they are very, very close together is called a compression. The parts that they are far apart and spread out is called a rarefaction. Again, they look like slinkies. They move parallel. Sound is an example. Compression, rarefaction. Wavelength is still the same. It's the distance between each successive part, but it's usually from compression to compression or rarefaction to rarefaction. Just where is it all kind of bunched up to the next part of where it is bunched up. We didn't actually get to the wave calculations. You are welcome for that. You will have to learn this in either chemistry or physics down the road. But all that we were going to do was velocity is equal to frequency times wavelength. That's all. And with that, we are finished. So guys, good luck on the quiz. Let me know if you have any questions. There's 7 questions in total. Go ahead and maybe breeze through this real quick before you take it. And also don't forget that you can use your notes / like that drawing that we did that first day. That would probably be pretty useful. All right. And with that, I will probably make one last video before I see you for the final time. Well, I guess you see me for the final time. Either way.